right, so today we're going to do day 4 of our notebook, which is going to be dilations. A dilation is a similarity transformation that enlarges or reduces a figure proportionally. Dilations are completed with respect to a center point and a scale factor. Is a dilation an isometry?
No.
No. Why not? What is an isometry supposed to do?
Same size.
Same size, same shape, right? So this keeps it the same shape, but not the same size. It's going to get bigger or it's going to get smaller. Dilations in the coordinate plane. To find the coordinates of an image after a dilation centered at the origin, it's very simple. All you have to do is multiply your x and your y coordinates by the scale factor. A lot of times you'll see the letter R used for your scale factor. Okay? So in my coordinate notation, I'm going to say the point xy dilates to R times x, R times y. Okay? So, example, triangle ABC has vertices A, -2, -2, B, 1, -1, and C, 2, -4. Find the image of triangle ABC after a dilation centered at the origin with a scale factor of 2. So the first thing I'm going to do is I'm going to draw my original figure. So my original pre-image is A is at -2, -2. B is at 1, -1. C is at 2, -4. So here's my original pre-image. And we are going to dilate that by a scale factor of 2. So my scale factor R is going to equal 2. So that means my original point xy is going to dilate to 2 times x, 2 times y. Okay? So let's see what our new points are. A is at -2, -2. What am I going to name my new image point?
A prime.
A prime. And so if I multiply both of them by 2, what am I going to get? -4, -4. So A prime, I forgot my prime, is going to be at -4, -4. A prime. And then B was at 1, -1. So B prime is going to be at 2, -2. Okay, and then C 2, 4 is going to become 2, -4 is going to become C prime at 4, -8. 4, -8. C prime. So here's my new image, and we can see with a scale factor of 2, it got twice as large as the original figure. It's also every point is twice as far away from the center. Remember, my center here is what we were dilating with respect to. Okay? So our dilation is what we call right here centered at the origin. That's when we can use this property. So that means every point is twice as far from the center. So B to the original B and to the new B, it's twice as far to the new B. From the center to C, I have to go twice as far to get to the new C. And so you end up with an image that's twice as big. Okay? So here we have 2 blanks to fill in, and keeping in mind that a scale factor enlarges or reduces a shape. If we have a scale factor less than 1, what do you think is going to happen to the pre-image? It's going to be reduced. And a scale factor greater than 1 will increase or enlarge the pre-image. Okay? It is important to note that your scale factor is always positive. You don't have a negative scale factor. So when we say it's less than 1, that means it's somewhere between 0 and 1. So like a half or 2/3 or 0.75. Okay? So it's going to be one of those little tiny fractional numbers less than 1. Will the following scale factors produce a smaller or a larger image? R equals 3? Larger. R equals 1/3? Smaller. It's a fraction. R equals 2.5? R equals 7/4? Larger. So that's one of those where a lot of times people will look at that and go, oh, it's a fraction, so it's smaller, right? But that's an improper fraction. Since the numerator is bigger, we know it's bigger than 1. So it's going to get larger. 0.998? A teeny bit smaller. And 6/5? Larger. Okay. Find the coordinates and graph the dilation after the given scale factor. My scale factor is 1/3. So do I expect my image to get bigger or smaller? Smaller. Okay, it should be 1/3 the size of the original. So A is at 0, 0. What do I get when I multiply by a scale factor of 1/3 if my x and y are 0? 0. So A prime is going to be at 0, 0. So A and A prime are at the same exact spot. Anytime you have something at the origin and you're dilating with respect to the origin, it'll stay where it is. Okay. Since I don't have them written in order here, let's just go down here to D. 3, -3. So D prime will be at what's 1/3 of 3? 1. And so then 1/3 of -3 is -1. So 1, -1. Here's D prime. This is A prime. C, 6, 0. So C prime will be at 2, 0. 1/3 of 6 is 2. Okay, and then the last one, B, goes to B prime, which will be the point 1, 1. And so here is my square that's smaller by 1/3. So that triangle has that square has dimensions that are 1/3 the size of the original quadrilateral. Okay? Now, it's not 1/3 the area, right? I could fit 9 of those little squares inside the big square, right? If it's by 1/3 and if that's a square. I could fit 9 of them in. So, it's not 1/3 the area of it, but it's 1/3 the dimensions of it. Okay? For its side length. Alright, so that is dilating about the origin. So that's really simple. If your center of your dilation is at the origin, it's pretty simple. It's just a multiplication game. That's all you're doing. When it's not the origin, it's a little bit more involved. So let's do a couple of those where we're not dilating around the origin. So when my center of dilation is not the origin, we're going to have to find the distance between the pre-image points and the center of dilation. Then we're going to use our scale factor with those distances to find our new points. And I put a little table here to kind of walk us through the steps of how we're going to do this, to kind of give us a little bit of help. Okay? So the first thing I'm going to do, it says dilate by 1/2, so we expect our figure to get smaller, right? Using a center of -3, 4. I'm going to graph that center, -3, 4. Here is my center. Okay. So then from that center, I'm going to start with, let's start with A. And my image on the graph, for some reason, is shifted up a little bit. I'm not sure why. Pretend those are actually on those coordinates. So A is right here at 5, -2. Okay? So I want to know from the center to A, if I was doing a translation to get from the center to A, what would my movement be? To get from the center to A, I'd have to go to the right, and I'd have to go down. It's 8 what?
To the right.
8 to the right, so that's plus 8. And then down, so minus how many? 6. We don't want to go over 8 and down 6. We want to only go over by a scale factor of half of that. So I'm going to take half of 8 and half of negative 6. Half of positive 8 is positive 4, and half of negative 6 is negative 3. So then, we're going to add those new changes to the original center. So my center was negative 3, 4, and we're going to add to that. So that's why it's plus the negative 3, 4. If I do 4 plus a negative 3, that's really 4 minus 3, which is 1. And then negative 3 plus 4 is 1. So A prime is going to be at 1, 1. My point B is the point 2, 2. So we're going to do the same thing. To get from the center to B, how far over and down do I have to go?
Right 5.
Right 5, so that's a plus 5.
Down 2.
And down 2, so that's a minus 2. Then I apply the scale factor to that. So my scale factor is 1/2. So 1/2 of 5, positive 2.5. 1/2 of negative 2, negative 1. Then we add that to the center, which is negative 3, 4. So negative 2.5 plus a negative 3 is negative 1/2, or negative 0.5. And then negative 1 plus 4? 3. I'm going to move this one over so I have room to label my point. And this will be the point B prime. So B prime is at negative 0.5, 3. And just so we can see what's happening here, right, to get from the center to B, I have to go over 5 and down 2. So if I only move half of that, I'm going over 2.5 and down 1. So I'm just moving half of the distance for each the left and the down. Or sorry, the right and the down. It's basically all that is accomplishing, all that math is accomplishing. And this will be B prime. Alright, so then last but not least on this problem C, the coordinates for C right now are negative 5, 2. So to get from the center to C, what am I having to do? Negative 2, negative 2. Go left 2 and down 2. So when I apply the scale factor 1/2 to the change, that's negative 2. 1/2 of negative 2 is negative 1. And then I add that to the original center. My original center was negative 3, 4. So negative 1 plus negative 3 is negative 4. Negative 1 plus 4 is 3. So C prime is the point negative 4, 3. And you can see it's halfway between, right? It's exactly halfway between. C prime. Here is my image that has been shrunk by a scale factor of 1/2. Now, generally, I'm not going to provide you with a table. That's just so you can see a way that you could organize your thoughts as you went through, if you're the type of person who needs to really organize your thoughts. Okay, some people can just look at it and see it and figure out how it's going to look. Some of us need to kind of really be organized when we do our math. Okay, and that's okay. I'm one of those people. I like to really organize everything out You'll see whenever I do any of my practice stuff, I always like show all my work, even though it's just something I've done for 20 years. It's just the way I am. All right, so on the next one, I'm going to dilate by a scale factor of 4. So am I getting bigger or smaller? Bigger, 4 times bigger. Using a center of 3, 4. So the first thing I'm going to do is I'm going to graph that center. So I'm going to graph the center 3, 4. 1, 2, 3, 1, 2, 3, 4. Here's my center. All right, and I'm going to start with A. A is currently 1, 2, 3, 2. So to get from 3, 4 to 3, 2, I'm not moving left or right at all, right? So that's just a 0. To get from, for the Y, to get from the center, I have to go down how many? I have to go down 2, so that's a negative 2. We want to take that change, and we want to multiply by the scale factor. My scale factor is 4. So I'm going to multiply this by 4, and I'm going to multiply this by 4. 4 times 0 is 0. Negative 2 times 4 is 8. Negative 8. So that's going to be my new change. I'm going to take that, and I'm going to add it to the original point, the original center. So I'm going to add the 3, and I'm going to add the 4. That is going to give me A prime. 0 plus 3 is 3. Negative 8 plus 4 is, so A prime is going to be at 3, negative 4. Notice it's still straight down. It hasn't moved. If you draw a line from your center to the one that's furthest out, it should go to the one, it should pass through the one that is further in. Okay? Let's try B. B is currently the point 1, 2, 3, 4, 2. So my original change to get from 3, 4 to 4, 2, what am I having to do? Over 1, down 2. So that's over to the right, so plus 1. And then down 2 is minus 2. And you can even kind of look here and say, oh, I have to add 1 and I have to take away 2. So you just compare your x's and y's also. I'm going to take that and multiply it by the scale factor 4. 1 times 4 is 4. And negative 2 times 4 is negative 8. And then I'm going to take my original center and add the 3 and add the 4. And that will give me B prime. 4 plus 3 is 7. Negative 8 plus 4 is negative 4. 7, negative 4. And notice you can also see on the dimensions. Here this is 1 square apart. Here this is 4 squares apart. It is 4 times bigger, right? All right, the last one, C. C is at 2, 3. So to get from 3, 4 to 2, 3, from 3 to 2, I'm having to go left 1, so minus 1. And then from 4 to 3, I'm having to go down 1, so minus 1. I'm going to take my change and multiply it by the scale factor, which is still 4. So my new change is going to be 4 times negative 1 and negative 1 times 4. I'm going to add that to the original center, 3, 4, to get C prime. C C prime will be negative 4 plus 3? Negative 1. And negative 4 plus 4? 0. So C prime is at negative 1, 0. C prime. Connect the dots. There is my new triangle that is 4 times bigger than the original triangle. And again, each one of these distances multiplied by 4 would get you to your new one. So in other words, this distance here, which is the square root of 2, and then this distance here would be 4 square roots of 2. Anybody know how I knew without doing any math that this distance diagonal across the square is square root of 2? Think about one little block on this grid is a 1 by 1 square. And so when I go diagonal across it, it creates a 45, 45, 90 triangle. So x square root of 2. That's why we spend so much time on triangles. So we know these sort of things. All right, just a little bonus information there. All right, just a little bit more. We're almost done. Perimeter and dilations. The perimeter of the image will be equal to the product of the perimeter of the image. So if I have an image, let's say I have a triangle, and I tell you its perimeter is 7. If I then take that triangle and I apply a scale factor of 3 to it, then the perimeter would be 3 times 7, 21. So for example, if a square has sides of 4 centimeters and is dilated by a scale factor of 5, what's the effect on the perimeter? Well, the perimeter will be how much bigger? 5 times bigger. And we could see that if I drew a square and I said its sides are 4, that means its perimeter is 16. If I dilate that by a scale factor of 5, how big would my new sides be? 4 times 5. 4 times 5, 20. And then perimeter is going to equal 80. 2, 4, 6, 80. And if you look, 80 over 16 is 5. So that means 16 times 5 would have gotten me my 80. Okay? Questions? Okay. Example, the Smiths recently went on a family vacation. They had a picture from their trip made into multiple sizes. Find the perimeter of the image below. Perimeter of ABCD is 20. For some reasons, I looked back at my notes from last year, and there are primes on the second picture, and I don't know why this year they didn't print out. But this picture should have the primes on it. This is the enlarged version. So I know since I'm getting bigger, I know my scale factor should be larger than 1 when I get it. Okay? And this is going to be, when you're doing something like this with dilations, it's going to have to be done with proportions. And so that means you're going to have to make sure you're dealing with total distances from one thing to another. Okay? And you're going to have to pay attention to where you're going to put things on the top and where you're going to put things on the bottom. Okay? So I know that the perimeter of this one is 20 centimeters. I want to find the perimeter of the new one, of the image. Okay? I'm not going to be able to find the perimeter unless I can figure out what the scale factor is. To figure out what the scale factor is, I need to know how long this little piece here is. How can I find out how long this piece is? Yeah, so 68 minus 32 is going to give me 36. Okay? So remember the center of dilation from the center to the image, and then compared to the pre-image, and then that same thing compared to the image will give us our scale factor. Okay? So, if I'm going to the image, what is that distance? 68. And then if I'm going to the image, that is 36. So 68 over 36, that's going to give me my scale factor. That will also give me the ratio of the small, or of the big, because I've got the bigger number on top, to the small. So when I'm looking at my perimeters, where is this 20 going to go on the next fraction? Is it going to go on the top or on the bottom? Does it go with the 36 or does it go with the 68?
68.
The 20 goes with the small picture. Yeah. Watch what happens, just so we can see. I want you to see, well, no, let's do it right first. Okay. The 20 goes with the small picture. That means it goes with the small. I'm trying to find the big perimeter, so it's going to go with the big distance. Okay. When I cross multiply, 36x equals 68 times 20, 136. Did I do that right? Oh, with a 0 on the end? I multiplied it by 2. I forgot to multiply it by 20. And then I need to divide that by 36. And I get a decimal. That's okay. We'll round it to 3 places. My new perimeter is going to be 37.778 centimeters. Okay? So this perimeter is approximately 38 centimeters. Which makes sense because my small one is 20. It's going to be a bigger one on the bigger picture. If I had done it upside down, because I want you to see what to watch for and how sometimes y'all turn in answers and I can tell that you said, that popped out of the calculator, it must be the answer, and you don't think about why that doesn't make sense. If I did it backwards, if I did 68 over 36 and I got the second fraction backwards, so I ended up with 68x equals 36 times 20, 720. And then I divide by 68. I get x equals 10.588. So that's saying the perimeter of this one is about 10.6. And at that point you should go, well, if this one's small and it has a perimeter of 20, it doesn't make sense that this one would have half the perimeter. Right? So at that point, that should indicate to you, oh, I must have one of my fractions upside down. Flip it over and try again. Yeah? So just kind of something to watch out for. An easy way to tell if you got your fractions upside down. Okay? Another common mistake is accidentally using this 32 instead of using the whole 68. So it has to be the whole distance from the center, the whole distance from the center. Okay? The whole thing. Any questions on dilations? All right, that's all I have for you. Your assignment should be available in Schoology.